Very good afternoon to all of you. Myself, Dr. Sandeep, Associate Professor, Department of ECE, and we have with us Professor Aisiri, Assistant Professor, Department of ECE, VVCE. Today we will be covering the topic signals and systems. Yesterday, the topic on networks was discussed. On the screen, you can see the syllabus of the signals and systems. Basically, the first part is Fourier analysis, followed by sampling theorem and applications. When I say Fourier analysis, DTFS, CTFT, CTFT, and its applications, sampling theorem. Also, this time we have the digital filter part, filter designing and all, and also the DFT, the Z transform, the LTI system, that is analysis of systems in time domain, definition, properties, and so on. Okay. So with that, we have planned the session like this. We will have the overview of the subject for the first few minutes. I'm not going to say that we will be covering each and every concept what is there in the signals and systems course, but the idea is that what are the topics that will be there, and brief discussion on each one of them, followed by to take it, and we'll be giving some 5-6 minutes of time to complete the quiz, because it's hardly 4 questions. So it should not take more than 6-7 minutes. We'll give you time. After that, we will be discussing the questions that were given in the early quiz, followed by the some of the previous year GATE question papers related to signals and specific topics are present in signals and systems, and followed by the end quiz. So when the session ends, we will be giving end quiz, and you can do it. Okay, so that is the objective or plan for today's session. Okay, so let me start. So let me first define. Let's start with what is signals. Basically, signal is defined as function of one or more variables that convey some information on the nature of a physical phenomenon. For example, if I just write, it's just a function, right? So if I write f of x, this function is dependent on one variable. So x is the independent variable, whereas the value of the function, the value of x is the dependent variable. And when I write f of x comma y, this function is dependent on two variables, and the value of the function at particular specific values of x comma y will be the dependent variable. Okay, that is a signal. The example could be an audio signal or a speech signal, and an image signal, a video signal, and so on. And what is a system? System is an entity that accepts one or more inputs. It modifies it to accomplish a certain function, thereby yielding a new set of signals. So when I combine this, say you have a system, and you have an input to the system and an output. Okay. So input signal and the output signal. Okay. So once we have this, the classification of signals. In the classification of signals, I can say continuous amplitude and the discrete amplitude, Okay, so when I say that continuous amplitude, it means that amplitude is continuous. When I say discrete amplitude, amplitude is discrete. For example, the continuous amplitude function. Simple function. I can just say so t, right? So x of t. When I say the discrete amplitudes, specific values, amplitudes are discrete values. So it can have a specific value. Okay, not the intermediate one. Okay, when I say continuous time, and another one is discrete time. So when I say continuous time, this is also a continuous time, also a continuous amplitude. This is just the discrete amplitude, okay, this signal. And let me write the discrete time signal. So n and x of n. Say at n is equal to 0, 1, 2. So say 1, 2, and 3. 1, 2. So this is the discrete time. Can also have 3.3 value something. So it is discrete time and continuous amplitude function. And finally, we have the analog and the digital, which is continuous time, continuous amplitude. So this is an analog signal. And say I have the discrete time signal, specific values, specific instance of time. So it can have only one certain values. Say at 3 it is 0, minus 1 it is 0. So it can have some limited possible values. So this is another x of n. So this is discrete time and discrete amplitude. This is a digital signal. Okay. Okay. So next classification. Next classification is the periodic and the non-periodic. If a signal repeats its behavior after a certain amount of time, it is said to be periodic. Otherwise, it is non-periodic. Next is the deterministic, the random signals. And I have an appropriate function to describe the signal. Then it is said to be deterministic. Otherwise, it is said to be random. It is said to be random. The statistical parameters to model the signal. For example, the mean, the variance, standard deviation, and so on. Next could be the even and the odd classification. If it exhibits certain symmetry with respect to y-axis, say for example, this is an even function, minus 1 plus 1, 1, x of t. This is an even function, symmetry with respect to y-axis, whereas an odd function exhibits an anti-symmetry with respect to the y-axis. So minus 1, 0, 1. Minus 1 is the amplitude, plus 1 is the amplitude. So this is an odd function. Energy or power. If the energy of the signal is the finite, then it is said to be an energy signal, and if the power is finite, then it is said to be the power signal. In case of power, energy is infinite. Okay, so whereas here because energy is infinite for power signal, whereas power is some finite quantity. Here energy is the finite, energy is finite, so finite quantity, whereas the power is 0. Okay, so that's how the energy and power signals are classified. Moving on to next, it would be the operations on signals. Since there are independent variable and independent variables, the operation on a dependent variable could be the addition, then the multiplication, the amplitude scaling, just the scaling factor, and then the differentiation, provided it is the continuous time signal, and the integration, provided it is a continuous time signal. So this could be the possible operations performed on the dependent variable of the signal. If it is an independent variable, then it is time shift. Then the scaling, time scaling, and then the reflection. It has certain order in which it has to be done. Uh, First is you have to do the shift and then the scaling, then possibly the reflection. It is the same order in which it has to be performed. So this is the operations on the signals. It could be on dependent and independent variable. Okay. So next is the classification of systems. Systems can be classified as linear if it satisfies the homogeneous and superposition principle. The time invariant, if an identical shift in the input causes an identical shift in the output. Hello? There was a network issue. Hello? There was a technical glitch. Okay. So we finished, I think there was a network issue. I think we were discussing on the operation on signals. We said that the signal, there are two things. One is dependent variable and independent variable. When I say it is dependent variable, we perform operations like addition, multiplication, amplitude, scaling, differentiation, integration. Last two is only for the continuous time signals. Okay, and then when it is independent variable, we perform the time shift, time scaling, and time reflection. It has a precedence rule, and first is always the shift, followed by scaling, and then finally the reflection. Okay, so then we went on to say what is the class. We went on to discuss the classification of systems. A system is said to be linear if it satisfies the superposition and the homogeneous principle. Next, a system is said to be time invariant if an identical shift in the input causes an identical shift in the output. A system is said to be static if the output depends only on the present value of the input, and it is said to be causal if the output of the system depends on present and or past value of the input. A system is said to be stable if a bounded input gives us the bounded output. A system is said to be invertible if the output of the system can be obtained. If the input of the system can be obtained from the output using another system. So system 1 is invertible, whereas system 2 is the inverse of the first system. Okay, so next we will try to obtain the time domain description of IK system. So we will move on to the concept of the convolution. Say suppose I have a continuous time system whose impulse response is say h of t, and say I have input x of t then the output y of t can be obtained using the concept of convolution integral, which is nothing but tau is equal to minus infinity to plus infinity x of tau into h of t minus tau d tau. Similarly, for discrete time, we have, say, x of n is the input and h of n is the impulse response of the system. Then y of n is given by summation n is equal to minus infinity to plus infinity x of summation k is equal to minus infinity plus infinity x of k into h of n minus k. Okay, I think the screen was not shared. So we have written this. That is input is x of t and output is y of t. So we can determine the response of the system to any arbitrary input if the impulse response of the system is known using the concept of convolution integral, which is y of t is equal to tau is equal to minus infinity to integral of tau is equal to minus infinity to plus infinity x of tau into h of t minus tau d tau. Similarly, if I know for a discrete time system, if I know the impulse response of the system, if I know this, then I can determine the response of the system y of n to any arbitrary input x of n using the concept of convolution summation k is equal to minus infinity to plus infinity x of k into h of n minus k. Okay. Why is this impulse response so important? Because with the concept of impulse response, we can classify the system. That is, if h of n is of the form c into delta of n, then the system is said to be static. And if h of n is equal to 0 for n less than 0, then it is said to be the causal. And if same conditions can be obtained for continuous time systems, and h of n is less than infinity, that is, if h of n is absolutely summable, the system is said to be stable. And h of n convolved with h inverse of n is equal to delta of n, where h of n represents the impulse response of the first system, h inverse of n represents the impulse response of the second system. Then the system 1 is invertible, and system h inverse of n represents the impulse response of the second system. Okay. So this was through convolution we were trying to represent the input and the output of the HA system through the impulse response, right? Through the concept of convolution. Now we will try to obtain the frequency domain analysis of HA system using the concept of the Fourier. But before that, let me tell you that say suppose I have a system with impulse response h of t, and say input is x of t is equal to e power minus t. Something interesting happens. That is, y of t is equal to, we know that it is equal to tau is equal to minus infinity to plus infinity using the concept of convolution. We can write it as h of tau into x of t minus tau t tau. So tau is equal to minus infinity to plus infinity x of t is e power minus st. So e power x of t minus tau can be written as e power minus s into t minus tau d tau. So rearranging this, I can write it as using laws of indices. This can be written as e power minus st into e power s tau. E power s tau. Okay, so it is e power s tau. So rearranging this, because this is a function of tau, t can be taken as outside, so I can write it as e power minus st integral tau is equal to minus infinity to plus infinity h of tau into e power minus s tau t minus tau. Yeah, e power st. Sorry, this is e power st. So e power st. So it is e power st, and yeah, I'm so sorry for that. And e power minus s tau. Okay, so it's e power minus s tau. So e power st e power minus, yeah, e power minus s tau d tau. This represents h of s, which is nothing but the system transfer function or Laplace transform of h of t. So Laplace transform of h of t, which is equal to h of s. If it is hold good for impulse response, it should hold good for any other signal too. So the Laplace transform of x of t, which is nothing but x of s, the bilateral Laplace transform, it is nothing but t is equal to minus infinity to plus infinity. So x of t into e power minus st dt. So this is the Laplace transform. But we know that where s is the complex number, which is given by sigma plus j omega. So if sigma is equal to 0, then we get s is equal to j omega. Substituting that, we get it as so x of omega is equal to x of omega is equal to t is equal to minus infinity to plus infinity x of t, because this is j omega, so we get e power minus j omega dt. So I can say that we get Fourier transform. So Laplace transform is a generic one, whereas uh, the Fourier transform is a special case of the Laplace transform. Even similarly here, when we give to a discrete time LTI system the uh, z power n exponential input with impulse response h of n. This is the input, and this is the output, say y of n. Using the concept of convolution, again we can obtain it as. So if I give complex exponential as an input to an LTI system, I get back the same complex exponential as the output, followed by the h of z, where h of z is the system transfer function, which is nothing but the z transform of h of n. So z transform of h of n, which is equal to summation n is equal to, say, minus infinity to plus infinity h of n into z power minus n. If it holds good for the impulse response, then it should hold good for any other signal. So x of z represents the z transform of any generic signal x of n, which is given by summation n is equal to minus infinity to plus infinity x of n into z power minus n. Well, we know that z is equal to r into e power j omega. It's a complex number. If r is equal to 1, then we have e power j omega, which is nothing but x of e power j omega, which is equal to summation n is equal to minus infinity to plus infinity x of n into e power minus j omega. This is nothing but discrete time Fourier transform of x of n. So what I'm trying to say is the Laplace transform and the z transform is a generic one, which is applicable for all types of systems and signals. But whereas the Fourier transform is a special case of Laplace transform, and discrete time Fourier transform is a special case of z transform. FT and DTFT is applicable only if the signal is bounded, or it is applicable for the system only if the system is absolutely stable. Otherwise, you cannot apply. So just summarizing it, the time and frequency domain characteristics, if it is continuous and discrete, periodic and non-periodic, if it is continuous and periodic, then it is continuous time Fourier series, continuous time Fourier series is a mathematical tool used to obtain the analysis of a time domain signal. Whereas if it is continuous and non-periodic, it is continuous time Fourier transform. And if it is discrete and periodic, it is discrete time Fourier series. And if it is discrete and non-periodic, it is discrete time Fourier transform. And another important table would be the characteristics that a signal would change from when it is transformed from one domain to another domain. So in time domain and in frequency domain. Time domain and the frequency domain. So the signal can be continuous, discrete, periodic, and non-periodic in time domain. A continuous signal would become non-periodic in frequency domain, discrete would become periodic in frequency domain, periodic would become discrete, and non-periodic would become continuous in frequency domain. So for example, say I have a discrete time Fourier transform being applied, on x of n. Usually this is applicable for discrete and non-periodic. When I apply dt of t, discrete becomes periodic, non-periodic becomes continuous, which is nothing but the x of e power j omega or x of omega. So this will be continuous and the periodic. Okay. So the problem is that this is continuous and periodic, so we cannot have infinite values to store the frequency domain representation of x of n. So we sampled dtft to get dft. So dft is nothing but the sampled version of dtft, where dft of any signal x of n is given by x of k, which is equal to summation n is equal to 0 to n minus 1 x of n into e power minus j 2 pi by n kn, where k would vary from 0 to n minus 1. But DFT was the number of complex multiplication and addition would be quite more. So they improvised and got the fast Fourier transform, which can perform in a faster way the DFT, which is nothing but the FFT, the fast Fourier transform. Finally, you have the filters. So filters, nothing but it can be classified into the FIR, finite impulse response filter, and the infinite impulse response filter. So FIR filter, so for example, it is characterized with using this equation. Say output is say y of n, then if it is a causal and finite duration, n is equal to 0 to n minus 1. So h of n into x of n minus k. This would be the difference equation description for the finite impulse response system. So when I say we are thinking about FIR filter, so it's nothing but it is characterized by the coefficients h of n. Okay, when it is IAR, the difference equation description that we use. So basically, we try to represent in terms of system transfer function. So if I want to say that, then it is for FIR, it is h of z is equal to say summation n is equal to 0, or it could be the sorry, I'm so sorry, this k here, h of k into x of n minus k. So sorry. So here h of z is equal to summation n is equal to 0 to n minus 1. So this is the system transfer function h of n into z power minus 1. So which we have written is nothing but z power minus n, z transform of h of n, which is h of z. Okay. So here also we can apply z transform this, which is y of z, x of z into z power minus k. So we get h of z, which is nothing but the alternate equation would be summation k is equal to 0 to n minus 1 into h of k into z power minus k. So if you can write it for n also, right? So this is h of z. So then k is just a dummy variable. So I can write n is equal to 0 to n minus 1, h of n into z power minus n. That's it. Okay. So for IAR, it is the for second order. Let me write it for second order. So it is h of z is equal to, which is given by say b naught plus b1 uh, into z power uh, z inverse plus b2 into z power minus 2. A naught is 1, 1 plus a1 into z inverse plus a2 into z power minus 2. So when someone is talking about the IR filter, it is about designing or obtaining of b naught, b1 and b2, or a naught is 1, so a1 and a2. So this is about the overview of the signals and systems for the gate. Now, in a short while, you will be given the early quiz. Kindly take the early quiz, and we will get back to you shortly. Okay? Yeah. Thank you so much.
Good afternoon, everyone. I'm Aisiri EP. So we have got about 4 responses for your for the quiz that we have given. So now we'll discuss the questions. So the first question that we had was, let y of n denote the convolution of h of n and g of n. So we have the input as g of n and h of n is the impulse response to an ADI system, and h of n is given as h of n is equal to 1 by 2 to the power of n into u of n, and y of 0 is 1 and y of 1 is 1 by 2. So if we plot these two sequences, what we'll get? So at n is equal to 0, my y of n is 1, and at n is equal to 1, y of 1 is 1 by 2. So similarly, if I plot h of n, so at n is equal to 0, 1 by 2 to the power of 0 is 1. At n is equal to 1, 1 by 2. At n is equal to 2, 1 by 4. It continues. So if you compare h of n with, this is y of 0. So if you compare h of n with y of n, you can notice both the sequences are equal. So you have the relationship, that is convolution, which relates your input with the output. Y of n is equal to x of n convolved with h of n. In this particular question, x of n is nothing but g of n. It is convolved with h of n. So we notice that our output of the system y of n is equal to h of n. So when can I achieve this condition where y of n is equal to h of n? When this g of n is equal to an impulse function. So now my g of n is equal to delta of n. So as you all know, delta of n exists only for the value n is equal to 0. At all other values, it is 0. So now from this particular equation for delta of n, I can represent delta of n as it is 1 for n is equal to 0, and it is 0 otherwise. So with this equation and the graphical representation for delta of n, which is now equal to my g of n. What is g of 1? G of 1 is 0, because at 1 my value is 0. So the option A is correct. So next we had the question, for the system 2 by s plus 1, the approximate time taken for a step response to reach 98% of the final value is option A 1 second, option B 2 second, option C 4 second, and option C as 8 second. So we have given. Okay, I hope you are following the questions with the Google form. So now what I had. So I'm having a system transfer function, that is h of s, which is given by 2 by s plus 1, and it is saying the approximate time taken for a step response. So the input is now, you can represent it as x of s is step response, and you take its Laplace transform. So that would be so I'm given with the x of t as step response. So I'm taking the Fourier transform of this x of t, Laplace transform of this x of t, that is x of s, that is 1 by s. So I know the system transfer function, I know the input, so I can get my output y of s as the multiplication of the system transfer function with the input x of s. So what did I have? It is 2 divided by s plus 1 into 1 by s. So if I take partial fraction on this, what would I get? So partial fraction, by applying partial fraction, the result will be 2 divided by S into S plus 1, which is equal to A by S plus B by S plus 1. So using partial fraction, I'll be able to calculate the variables A and B, which is equal to 1 and minus 1. Therefore, the system transfer function, the equation get reduced to 2 into A into so that is, now I have the value for A as 2. So sorry, this is A is equal to 2. So I have the value that is Y of S is equal to and B is minus 2. So then that is 2 divided by S minus 2 divided by S plus 1. So if I equate this, so if I take its inverse Laplace transform, I would get Y of t as 2 into U of t minus 2 into e power minus t into U of t. So if I simplify this, my Y of t would get reduced to 2 minus 2 per e power 2 into e power minus t into U of t. So now the question is asked to find the 98% of the final value. So the final value is represented by YSS of t, which is given by for t for limit, that is t tending to infinity, which is of y of t. So the final value of y of t is the limit where t tends to infinity. It is taken to be 0. So that is, you'll get the value as 2. So you have the final value of the e power minus t is equal to 2 into 0.98. So let the time taken to reach the 98% be represented as t of s. So if I go on equating, the answer would get reduced to 0.02. Sorry, this is 0.02, which is equal to e power minus ts, and then ts will give me ln of 50, and then this is 3.91 seconds. So that is 4 seconds is the answer. That is option C is correct. So next we had the question. The frequency spectrum of a signal is shown so the question that we have is shown here. It is a millisecond. The frequency spectrum of the sample will be. So what is the frequency spectrum of the sampled signal look like? So I have a signal which is given by, this is u of j omega 0, and this is 1 kilohertz from the given data, and this is omega. So it is saying that it is sampled at the rate of 1 millisecond. So that is 1 millisecond. So if I sample this particular signal at the rate of 1 millisecond, so that is at 1, I have its replica, at 2, I have its one more replica, at 3. So at the intervals of 1 milliseconds, same is applied to the negative axis. So so the sampling frequency would be 1 kilohertz, which is given in the data. So next, I'll be having, when I sample this particular signal, I'll be having the replicas at the intervals, like at 1 millisecond, I have one replica. Again, at 2 millisecond, I have one more replica. At 3 millisecond, I have one more replica. This continues because they had given the sampling frequency or the sampling interval to be 1 millisecond. So at 1, I have, at 2, I have, and at 3, I have, I'll be having at 4. So this continues similarly for the negative axis. So this is This is resulting the aliasing condition. So you can see here, aliasing is happening over here. There is an overlapping of the replicas, which results in no faithful reconstruction of the original signal. So what is the frequency spectrum of the signal now? So that will look like, if this is omega, so this frequency spectrum of my sampled signal will look like this. So that is option D is correct. So this is about next question. So next we had the following is true. So we have given few statements regarding signals. The first statement says the finite signal is always bounded. So let's see, is it true or what is the condition? So following, like what the first condition says, the finite signal is always bounded. So say suppose you have some finite signal. So this is the finite, this duration is finite. So I'm representing this particular signal as a finite signal. So this finite signal, so that's saying it to be, the first statement says it should be bounded. It need not to be bounded. When you consider the condition under asymptotic condition, which means to say they'll meet at infinity. So if this is finite, but there is no guarantee that they'll be bounded. So that under asymptotic condition, this particular condition will not be satisfied. They'll not be bounded. So they will be bounded at the infinity. So the first statement goes wrong. And then we had a bounded signal is always zero outside the interval minus T naught and T naught. Suppose this is the interval T naught and I have some signal like minus T naught here. So that this need not to be zero. This can have any other value for some T naught. So it will have some for value at some T naught, right? So there is this particular statement, that is C, also goes wrong. And then we are saying a bounded signal is finite. If this particular signal, I'm considering this particular bounded signal, this is a bounded signal. This cannot be, this can be finite, or it can reach, or it will be reaching its, or it will end this the bounded signal can reach up to infinity. So this can never be, or you cannot have a guaranteed statement to have this particular equation or particular signal to be finite. So if you have a bounded signal, there is no guarantee of that it will exhibit finite, that it is finite. If you have a finite length of sequence under asymptotic condition, it will not be bounded. And according to the statement C, the bounded signal will not be zero for some T naught. So that is, all the three statements would go wrong. And the statement D, that is a bounded signal, will always have a finite energy. So that statement, so the option B is correct. So that any finite signal or bounded signal will always possess a finite energy. So this is about the questions that were given in the early quiz. So now we'll look into some few concept oriented questions that were taken from the GATE question papers. So the first question says, first we'll be covering the questions that comes under convolution and time domain representation of signals. So the first question says, given the finite length input x of n and corresponding finite length output y of n of the LTI system, which is shown below, impulse response h of n of the system. So you are asked to find the impulse response of the system. So this kind of questions are nothing but system identification questions. You should be able to identify what kind of sum of that particular function would give you h of n. But that's the conventional method and it takes your time. So in GATE exam, time is the key factor, and you should be able to reduce time as much as possible. So the better or the shortcut way to solve this particular problem would be, so I am knowing the value for x of n. X of n is equal to minus 1 comma 1, and I know the value for y of n. So y of n is given by 1, 0, 0, 0, and minus 1. So we know if you know the length of the sequences L1 and then L2, which would preferably be the input and then the impulse response, the output, the length of the output sequence is given by L1 plus L2 minus 1. So with this formula, I'll be able to calculate what is the, we know L1 and we know what is L because it is 5. That is nothing but the output sequence. And this is L1, that is 2. So using these two values, I'll be able to calculate what is L2. So L2 is now 4. So with this answer, I am now reducing, or I'll be able to eliminate two of the options, that is B and D, which are of length 3. So those two will not be the answers for sure. So I'm left out with the options, that is A, which is 1, 0, 0, 1, and one more option, C, that is h of n is equal to 1, 1, and 1. So now if I calculate convolution by using any of these two sequences, the result y of n will give you the answer. You need not to calculate for these two as well. If you calculate for this, if you get the different y of n, this will be the answer. If you calculate for this and if you get different answer for y of n, this will be the answer. So this is how we can calculate, you'll be able to know what is the impulse response of the system in a shortcut method. So next we have the similar kind of question, or the question that falls in the same section, that is a linear time invariant system with an impulse response h of t produces output y of t when input x of t is applied. When the input x of t minus t is applied to a system with the impulse response h of t minus tau, the output will be. So if you read this question carefully, this needs no calculation. This is just a guessing part of the questions, wherein you will be able to know the answer just by some analysis. So you know, when you say the system is time invariant, there will be an identical shift in the output for an identical shift in the input. So there is an identical shift in the input, that is x of t minus tau, and it has been applied to the impulse response, even that has been shifted by tau units. So in total, the output will be shifted by 2 units. So the answer will be the option D, that is y of t minus tau. So using the properties of the system, that is linear time invariant, you can have the statement like whenever there is an identical shift in the input, this will give an identical shift in the output. Using that particular property or statement regarding the system, you'll be knowing what is the output of the system. So you have the shift in the input x of t minus tau, and this has been applied to the impulse response, that is shifted by h of t minus tau. So in total, the output will be shifted by 2 units. So the answer is y of t minus 2 tau. So moving on to the next one. So the next I have, given a sequence x of n, to generate the sequence y of n is equal to x of 3 minus 4n, which one of the following procedures would be correct? So for this, it is always better to follow this convention wherein you perform shifting first and then you perform scaling and later you perform reflection. So we'll see, here you have to analyze, or you'll have to decide what is the answer by examining through all of the options that you have. So the first option says, according to the first option, first delay x of n by 3 samples to generate z1 of n, then pick every fourth sample of z1 of n to generate z2 of n, and then finally time reversal. So it is first delay, which means to say it is shifting, and then pick every fourth sample, it is scaling, and then time reverse, so reflection. So the sequence is correct. So let me check whether y of n will be x of 3 minus 4n. So it is first saying, so the first, it is saying delay x of n by 3 samples. So my z of n would be, so delay x of n by 3 samples, and then you'll get z2 of n, which says once after delaying to pick every fourth sample of z1 of n to generate z2 of n. That is, you have to pick every fourth sample, that is x4n minus 3, and then after this time reverse z2 of n to get the y of n. That is, z2 of minus n would give me y of n according to the option A. It is saying first delay it by 3 samples, take every fourth value, and then reflect the signal to get y of n. So if I do this, what is the answer? That is x of minus 4n minus 3, which is not equal to x of 3 minus 4n. So the option A goes wrong. So when I check it for option B, so option B says first advance x of n by 3 samples. Advance x of n, that is my z1 of n will now be x of n plus 3. Sorry. Advance x of n by 3 samples, and then pick every fourth value of z1 of n, that is x of 4n minus 3, sorry, plus 3, and then obtain y of n by performing time reflection, that is time reversal, z2 of minus n. That would give me x of 3 minus 4n, which is equal to x of 3 minus 4n. So I have obtained the answer as option B. So if I just examine these remaining 2 options, so it is saying option C, according to the option C is saying first pick every fourth sample. Pick every fourth sample, which means to say your V1 of n is now first it is asking to perform scaling. So that is x of 4n, and then it is asking to generate then time reverse V1 of n, that is reflect this V1 of n to get V2 of n, which is equal to V1 of minus n, that is x of minus 4n, and then you just shift it. So that is advance V2 of n by 3 samples. V2 of n by 3 samples. What does this gives me? So this is x of minus 4n plus 3. So which is, sorry, n plus 3, which is not equal to x of 3 minus 4n. Similarly, examining D, there it is asking the same thing, that is obtain or take the fourth sample of x of n. This is scaling, and then V2 of n, perform time reversal, that is the same thing, x of minus 4n. Then y of n is delay every sample of n by 3 units, that is x of minus 4 into n minus 3. This will definitely not be equal to x of 3 minus 4n. So this is how you will find the answer by examining the answers given for a particular problem. So now moving on to the next one. So we'll take up problems from Z transform. So it is given like the Z transform of a signal x of n is given by 4z to the power of minus 3 plus 3z to the power of minus 1 plus 2 minus 6z square plus 2z cube. So it is applied to a system with a transfer function h of z is equal to 3z to the power of minus 1 minus 2. Let the output be y of n. So according to by using this transfer function and then x of n, which of the following statement is correct related to the output y of n? So we are given with x of n. So x of n is nothing but 4z to the power of minus 3 plus 3z to the power of minus 1 plus 2 minus 6z square plus 2z cube. So, sorry, this is x of z. I'm so sorry. So, this is x of z. So, by this, I'll be able to get x of n, which is, that is the starting sequence 2, and then it is 3, and then it is 0, and then it is 4, and here you have 0, and then you have minus 6, and then you have 2. Similarly, we have h of z. H of z is equal to 3 z to the power minus 1 minus 2. So with this, I'll be able to get h of n, which is equal to minus 2 comma 3. So with this, now I'll be able to perform convolution. So convolution of this x of n with this h of n minus 2, 3. So that would give me 2 minus 6, 0, 2, 3, 0, and then 4. So that is minus 4 comma 6, that is plus 12 comma 6, 0, 0, minus 4 comma 6, then this is minus 6 comma 9, 0, 0, minus 8 comma 12. So the result y of n. So this is now x of n, and this is h of n. So the result y of n, I would obtain it as minus 4, that is, then you have 18, and then you have 6, and then you have minus 4, and then you have 0, and then you have 9, and then you have minus 8, and then you have 12. So the starting of this particular, or the indicator is at 2. So if I'll be able to represent that particular equation like this. So now the sequence was starting at 2. So that is at indexing was at this particular point, n is equal to 0 was here. Sorry, this is n is equal to 0, 1, 2, 3. So that is 0, 1, 2, 3. So at 3, the index or the indicator or the pointer was at 3. So the output sequence will also have the pointer at 3. So if I represent this particular sequence with this notation, now we'll try to check which of the following statement is correct. So the first statement says y of n is non-causal with finite support. So yeah, this is having a finite support. This signal is finite. Is it non-causal? So non-causal, for the condition, the system is said to be causal if y of n is equal to 0 for n less than 0. So is y of n 0 for n less than 0? No. You have the values. So this for n less than, you don't have the value for n less than 0.
Zero sample. You have the 0 less than 0. So this is non-causal.
Yeah. So first option. Yeah, sorry. I'm so sorry. So yeah, you have the value. You have the values for the n which is less than 0. That is why the system is non-causal as well. So you would obtain the answer at the very first option itself. So we'll try to examine other options as well. The option B says y of n is causal with infinite support. So infinite support, it is wrong because you are having a finite support. And then at C you have y of n is equal to 0 for mod n greater than or equal to 3. So what does this mean? Y of n is equal to 0 for mod n which is greater than 3. No, it is not equal to 0 for n which is greater than 3. So yeah, there is the which is greater than or equal to 3. You have the value. You don't have a value which is 0 for mod n which is greater than 3. So that is also wrong. And then fourth option you have y of n is non-causal with infinite support, because yeah, it is non-causal but it is having finite support. So the option A is correct. So now we have one problem. So x of z is equal to 1 minus 3 into z to the power minus 1 and y of z is equal to 1 plus 2 into z to the power minus 2 are the z transforms of two signals x of n, y of n respectively. So a linear time invariant system has the impulse response h of n, which is defined by the two signals where h of n is equal to x of n minus 1 convolved with y of n, that is the star denotes the discrete time convolution. Then the output of the system for the input delta of n minus 1 would be, so you have four options. So it is given like so we have x of z, that is 1 minus 3 into z to the power minus 1 and then y of z, which is equal to 1 plus 2 into z to the power of minus 2. So if I take inverse z transform, I'll get x of n as 1 comma minus 3 and then y of n as 1 comma 0 comma 2. So now I know what is x of n and I know what is y of n. So I'll be able to get y of n, which is equal to, or you should now calculate what is h of n. So using the normal conventional method, that is by applying z transformation would take time. So how will I obtain the shortcut method? So y of n is given by x of n convolved with h of n. So it is saying, so I'll be taking, first of all, I don't know what is h of n, so I know x of n and y of n. So I want to calculate what is h of n. So h of n, I'll be able to get this particular h of n using this particular formula, that is x of n convolved with this y of n. So now this y of n is nothing but we are taking it to be the second sequence to perform the convolution. So I know what is x of n and I know what is y of n. So to have x of n minus 1, so what is x of n minus 1? The question says h of n is given by x of n minus 1 convolved with y of n. So I want to obtain x of n minus 1. So how will I obtain x of n minus 1? So that is, I'll delay the sequence. So that is 0, 1 and 3. So n is at 0 now. So now to obtain this particular h of n, x of n minus 1 will be convolved with y of n. This is given in the problem. So that is, I have x of n minus 1 and I know what is y of n, 1, 0, 2 convolved with 0, 1, minus 3. So that is 0, 0, 1, 0, 2, minus 3, 0, minus 6. So my h of n is equal to 0, 1, minus 3, 2, minus 6. 0, 1, minus 3, 2, and then minus 6. But what is the input? So the output of the system for the input. So the question is to find what is the output of the system when the input delta of n minus 1 is applied. So when I multiply this particular delta of n minus 1 with the input, so the input is now replaced with delta of n minus 1. So I can now modify the system output as, that is x of n convolved with, sorry, this is h of n convolved with delta of n minus 1, because this is the input to the system. So what will I get? That is h of n minus 1. So the output is now equal to h of n minus 1. I have h of n which is equal to 0, 1, minus 3, 2 and minus 6. H of n minus 1 will be 0, 0, 1, minus 3, 2 and minus 6. So this is the delayed version of h of n minus 1, which would give me y of n. So with this, I'll be able to get the answer, that is, which is equal to, if I represent this using the delta function, that is 0 delta of n minus 2 at this minus 3 into delta of n minus 3 plus 2 into delta of n minus 4 minus 6 into delta of n minus 5. So this is option B is correct. So this is about the first 5 questions which would be asked frequently in the GATE exam, and next set of questions will be discussed by Professor Sandeep. Thank you.
Yeah, good afternoon, students. So I'm again back. So these are the previous year GATE questions that we have selected. We have segregated based on the topic, and some of the concepts that we learn here would be applied frequently. So we have chosen like that carefully, so that within the limited period of time, we wanted to cover the maximum concepts. Okay, so some problems require intuition thinking, some problems require calculations, and so on and so forth. So we have tried to cover all types of possibilities for a limited period of time. Okay, the next question is, if u of t is the unit step and delta of t is the unit impulse function, the inverse z transform of f of z is equal to 1 by z plus 1 for k greater than 0, right? So let me go to the notepad. Okay, so f of z is equal to of given f of z. So f of z is equal to 1 by z plus 1 for k greater than 0, correct? And this is the inverse z transform given, the inverse z transform. So this is the z transform given. So we have to determine the inverse z transform of f of z, right? So what we can do is, like, we can do in a traditional way, apply inverse z transform and so on. But instead of that, what we can do is, for this typical question, we can apply z transform on the choice, z transform on the choices, and then try to get the answer. So what we can think is, okay, now the first option that is given is minus 1 to the power k into delta of k, right? So we know from the property that x of t multiplied with delta of t minus t naught is equal to x of t naught, that is, this function gets evaluated t naught into delta of t minus t naught. This is the property. It applies for discrete and continuous. So here, doing that, I can write that this function gets evaluated at 0, because it is in the form of delta of k minus 0. So I have to evaluate this function at 0 into delta of k, which is nothing but delta of k itself. What is the z transform of delta of k? It is 1, which is not the given answer. So that is why it cannot be the first option. What about the second option, which is nothing but delta of k minus 1 power k? And please remember, k is greater than 0. So all these things applies for k greater than 0. So let's try to apply this z transform of k, delta of k. Just now I have discussed, it is 1. And this is in the form of minus 1 power k, right? So we know the standard form that alpha power n into z power n will have z transform z by z minus alpha, correct? So provided magnitude of z is greater than alpha, correct? So this is what we have. So here we can apply that for k greater than 0. Similarly, we can write this as z by, in place of alpha we have minus 1, so z plus 1. So simplifying this, I can write it as z plus 1 minus z by z plus 1. Plus and minus z would get cancelled, so I'm obtained with 1 by z plus 1. So that is why the second option would be correct. So you would be stuck, like, how do I apply the inverse z transform? Is it through the division method, or is it through using the properties? So you'll be stuck. Instead of that, the tip or the technique that we are teaching here is, when you are stuck in that, use the choices, apply the z transform, and get whether you get the point in the question. So that's the moral from this problem. Okay, let's try to go for the next problem. So that's about some of the problems in z transform. Okay, next we have, let me read out the question. Let the Laplace transform function f of t, which exists for t greater than 0, be f1 of s. Okay, so f1 of s and ft form a Laplace transform pair. Okay, so let me write that first. f1 of t and f1 of s form a Laplace transform pair. Okay, and they've given that Laplace transform its delayed version uh, f of t minus tau. So f of t minus tau. So let me call this as f2 of t, which is nothing but f1 of t minus tau. So the Laplace transform of it. They said that f2s represents Laplace transform of that. So which is nothing but shift in time domain corresponds to multiplication by exponential. So it is e power minus s tau into f1 of s from the given problem, okay, from the given question. And okay, so s is equal to sigma plus j omega. If g of s is equal to, if they've given that if g of s is equal to f2 of s into f1 conjugate of s by magnitude of f1 of s square, then the inverse Laplace transform of g of s is n. So they are asking us to find g of s is related to f1 of s, f2 of s like this. They're asking inverse Laplace transform of g of s. So we'll try to simplify the given question itself. So f1 magnitude square of f1 of s can be written as numerator as it is f2 of s into f1 of conjugate of s by f1 of s into f1 conjugate of s. Okay, this is nothing but the magnitude, because say I have a complex number a plus jb, I have a complex number a minus jb. So if I take the product of this, then I would get the magnitude square. So it is same as this. And so if I know this, I can cancel this. So I'm left out with f2 of s by f1 of s. But what is f2 of s? It is e power minus s tau into f1 of s by f1 of s. f1 of s would get cancelled and e power minus s tau. Now see, the problem has reduced to so simple that we have to take the inverse Laplace transform of e power minus s tau. So here if you see that, let me tell you the formula. So the Laplace transform of delta of t is 1, whereas the Laplace transform of delta of t minus tau is e power minus s tau. So here we are trying to ask the inverse Laplace of e power minus s tau, which is delta of t minus tau, and hence the inverse Laplace transform of g of s is equal to delta of t minus tau, and the option is the delayed impulse delta of t minus tau. So the option B is the answer for the second one. I think for the first one I already told you the option B. Again here also it is option B. Okay, and here also it is option B. That is about the Laplace transform. Okay, next let us try to do the Fourier analysis. Even in Laplace transform you get similar problem. We have already discussed one similar question in the early quiz. We had taken the concept. So here we have taken in the class one more concept. Okay, so now the next question is the Fourier analysis and DFT related part. Okay. Okay, the question is that let x of t is equal to rect of t minus half 0, otherwise if sinc of x is equal to sine of pi x by pi x, then the Fourier transform x of t plus x of minus t will be. This problem would require elaborate explanation. There are good number of similar problems to this, so you take bit extra amount of time to explain this problem, because similar kind of problems, if you understand the underlying concept, I think the questions may not be repeated, but the similar concepts would definitely be helpful for you to solve the other questions. Okay, let's write what they've given first. So first we should know the rect function. So what is rect of t? Okay, let me write it as rect of t itself, which is nothing but a function which stays from minus half to plus half. This is symmetric with respect to 0. Amplitude is 1. This is rect of t. What they've given, x of t is equal to rect of t minus half. So the function is delayed, shifted right by half time units, right? So let me write that. So let me write x of t as so shifted half means it will start from 0, it will go up to 1. So this is 0, this is 1, this is 1. So this is x of t, which is nothing but rect of t minus half. They also said you consider x of minus t. So what is x of minus t? Reflection of this. So let me write x of minus t, which is reflection of this. So t, reflection of this means here it will be 0 to minus 1, amplitude is 1. But not only that, they are asking us to determine the Fourier transform of x of t plus x of minus t. So when I combine these two functions, then I'll get a function which will have support as from minus 1 to minus 1 to plus 1, which says center is 0, and this is x of t plus x of minus t. Okay, so suppose let me call this as x1 of t. Okay, so we have got this, and they're asking what will be the Fourier transform of this function. So we have to determine the Fourier transform of this function. Okay, so but what we should remember is that the Fourier transform of the rectangular function will be nothing but sinc function. So and vice versa also holds good. Okay, so let's try to use it. Okay, so we have the standard. One second, let me clear this. Okay, so I think that should be sufficient for us. Okay, so I have this. So what we have a standard properties of Fourier transform, transform pair, which is nothing but if x of t is equal to sine of wt by pi t, its Fourier transform is nothing but x of omega, which is equal to x of j omega or x of omega, which is equal to 1 for mod omega less than or equal to w, 0 otherwise. Okay, so that means what graphically, if I want to say this is a sinc function, and this is time domain. In frequency domain, it will be a rectangular function. So with w as the support, minus w. Okay, so yeah, so this is how it looks like. But that is not what is given to us. It is always the other way around. That is, they have not given our time domain function is not a sinc function. It's a rectangular function. Please concentrate on that. So it's a rectangular function, whereas our transform domain will be a sinc function. So here we get something like this. So it is a sinc function, right? So it's a sinc function that we get. That is what we get here. So we have the other way. So, but we also have another property, which is nothing but the duality property, which is nothing but x of jt will have the Fourier transform 2 pi into x of minus omega. So what I'll do for this is, so let me take the eraser and okay, I want this. So okay. Okay. So the time domain description is there with me, which is nothing but say x1 of t I have called, right? So x1 of t, what I have got here, I'm trying to describe this, which is equal to 1. This amplitude is 1. Okay, this is nothing but sorry. This is nothing but this is nothing but x of t plus x of minus t. This is that function. So I'm trying to describe it. It is equal to 1 for mod t less than or equal to 1, 0 otherwise. Now you can see that there is some similarity between this definition and this, right? So here we have. So similarly, I can obtain this using the properties. I can write, say, x1 of omega equals using this. So I can write 2 pi into x of minus omega, right? So here we have this thing. So I can write this as 2 pi into, so here whatever is there in time domain, I have to, what it means is that multiply this with 2 pi, and wherever t is there, replace it with minus w. So sine of minus omega by minus omega will be sine of omega by omega. So I'm neglecting the negative sign here. So I'll write this as sine of, so here w is 1 here, isn't it? Here we have w is 1. So it becomes 1t. So I'm just writing it purposefully 1t, sine 1t. And instead of t, what I should write? Omega minus omega. So I'll just write it as omega itself. So sine omega. So 1 omega is nothing but sine omega by, so the pi omega. So instead of t, pi omega. So we have this, the Fourier transform. Now if is this pi would get cancelled, so we have got 2 sine omega by omega. Is that the options do we have? Definitely not. So it's not in directly. They're given in terms of sinc. So we have to use the definition of sinc. Sinc of x is equal to sine pi x by pi x. So from now on, whatever you do is slightly rearranging it. Okay, so let's, the first thought what you may get is, okay, let me rearrange it as it is. And so let me, what I'll try to do is that let me rearrange that particular term and okay. Okay. So I have this. So let me take this. Yeah. Two side. So sinc function definition, whatever they have written, let me write it for you. Sinc of x is equal to sine of pi x by pi x. Okay. So I have this. So now if I want to rearrange this, so 2 sine of, so pi is not there, so I'll multiply it with pi, but if I do so, I'll be modifying it. So multiply and divide by pi. So again, it is sine omega in there, and by omega is there. So instead of omega, I want pi into omega, right? So I have just the omega value. So what I'll try to do is, here I want the pi is also not there, pi, only just omega is there, pi into omega by pi. So again, it is just omega we are left out with, so we are not changing the any value. So it is in the form of sine pi x by pi x, which is the limit sinc of x. So again, you may write the answer as 2 into sinc of, this is x. So okay, to sinc of the pi omega by pi. Okay, you may think that is this the option do we have? Again, let us check. To sinc of omega by pi, did we get? No, that is not the options. But so again, we have to slightly rearrange this. So what we have to think is, okay, there's something like sine and cos is there. So what I'll try to do is, let me just go to the notepad. So what I'll try to do is I'll use this original thing, what we had, to sine of omega by omega, right? So I'll use the half angle formula for this, and I'll write, we know that sine theta is equal to 2 sine theta by 2 cos theta by 2. So writing this, and this 2 I'll just shift it down. So I'll write this as omega by 2, and this is cancelled. So same thing, right? So sine omega in the numerator is there, 2 sine of omega by 2 by cos omega by 2. So that's why I shifted that 2 downside. Now I have omega by 2. Okay, I have this omega by 2. Okay, so omega by 2. Now again, I can use the sinc definition here. So pi into x, right? So what I'll take, I'll just concentrate on this. Let me take another. So I want pi into x, right? So what I'll do is I'll multiply by pi and divide by pi. So it becomes omega by 2 pi. Similarly here, pi into omega by 2 pi. So I'll get it as, so this can be written as sinc of omega by 2 pi. So 2 into sinc of omega by 2 pi into cos of omega by 2. Okay, so First of all, if I try to do with the this thing itself, what if I try to use the half angle itself, I should be able to get that it is a 2 dash into cos of omega by 2. You should be ready with the answer that it is option C. But for the sake of completeness, I have shown you the complete step that we get the answer as 2 sine C omega by 2 pi. So one important tip that I would give in this problem is that please be familiar with this. That is sine Wt by pi t will have the Fourier transform x of omega is equal to 1 mod omega less than or equal to w, 0 otherwise, and the duality property. Based on this, numerous problems are appearing in GATE. So okay, so let me go to the next question. Okay, the last point is on DFT. Okay, again here, let x of k is equal to k plus 1. Let x of k is equal to k plus 1. X of k is equal to k plus 1 for k ranging from 0 to 7. So for k ranging from 0 to 7. So if you think that it is x of k is equal to, it is for k is equal to 0, I get 1. And for k is equal to 1, I get 2, 3, 4, 5, 6, 7, 8. This is for k is equal to 7. This is how the x of k looks like. Okay. And be a 8-point DFT of the sequence x of n. So x of n. So what can you expect when the sequence is? We know that if x of n is real, x of k exhibits the conjugate symmetry, correct? It exhibits the conjugate symmetry about the midpoint, correct? It exhibits the conjugate symmetry about the midpoint. Now vice versa. X of k is real, so x of n would definitely exhibit the conjugate symmetry. So we have again the 7 values. The 0th value, this is the middle point, 0, 1, 2, 3, 4. So this is the 4th midpoint, which is nothing but n by 2, because they are taking 8-point DFT. This is n minus 1. This is 0, okay? 0, and then 1, and 2, 3, 4, 5, then 6, then 7. This is nothing but 0th, this is nothing but n by 2, and this is nothing but n by 1. Okay, now you may think that, sir, we'll apply inverse discrete Fourier transform and then try to do it, and then literally determine after that the x of n is equal to 0 to 3, x of 2n. So, but that is not advisable. When I say x of 2n, x of 2n corresponds to what sample? 0th sample. I'm just writing whatever it is. 0th sample. Please remember this exhibits conjugate symmetry. So if conjugate symmetry means if one is a plus jb, another will be a minus jb. So one will have exhibit conjugate symmetry with the 7, and next 2 will be with 6, and next 3 will be with 5. Okay, so we have to comment on the 0th and the 4th value, right? So yeah, so let me write, after taking x of 2n, what values will be there? Let me write that. So 0th value will be there, one sample left out, it is 2, one sample left out. This is of original, okay? The indexing I'm writing, one sample left out, the 4th, one sample left out, it is 6th, and that's it, right? So we are, according to this, say suppose this is y of n, then it is 0th index, first index, second index, C. This itself I need to sum. Of what I'm trying to give a shortcut method is that whenever the x of k is having the linear increasing or linearly decreasing, all the real part of the values of x of n will have the similar value as that of 4. But what is 4? What is 0? We know that the first value, that is 0, will exhibit the average of x of k's. Average of x of k's in the sense, let me tell you mathematically what I'm trying to tell. So x of k is equal to, anyway, it is, x of n is equal to 1 by n summation k is equal to 0 to n minus 1 x of k into e power minus j 2 pi by n kn, where k ranges from 0 to n, where ranges from 0 to n minus 1. Say if I want to determine x of 0, what is x of 0? N 0. If you substitute n is equal to 0 here, n is equal to 0, then anything to the power 0 is 1, so this becomes 1. It is just nothing but here, there's nothing but x of 0 plus x of 1 and so on up to x of n minus 1. Basically x of n minus 1. Here it is. So it is x of n minus 1 by n. So it is nothing but average value. In our case, it will be, let me do the calculation here. So it will be 8 plus, okay. It will be 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 plus 8 by the endpoint DFT, which is 8-point DFT in our case. So if I add it, I will get 8 plus 7 is 15 plus 6 21 plus 5 26 plus 4 30 33 33 plus 2 35 plus 1 36 by 8, which is nothing but 4.5, which is nothing but 4.5. So the first value, without doing any IDFT and all those things, I can write the first value to be, let me write in another color. So it is the 4.5. Now what about the fourth value? So the fourth value is nothing but, let me write here itself, the fourth value. So similarly, if I am doing that, so using that formula again, so which is nothing but x of n equals to 1 by n summation k is equal to 0 to n minus 1 x of k into e power minus j 2 pi by n kn. So now n is nothing but, in this case, it is n by 2. So let me write out the formula first. So it is x of n by 2. I'm trying to determine generic one. So I'm giving a general tip. So 1 by n summation k is equal to 0 to n minus 1 x of k into e power minus j 2 pi by n. K is n by 2 into n. So n would get cancelled, 2 and 2 would get cancelled. So we are left out with e power minus j n pi, which is nothing but cos of n pi minus j sin n pi. Sin n pi is anyway 0. So we are left out with cos of n pi, which can also be written as minus 1 to the power n. So this can be written as 1 by n into summation k is equal to 0 to n minus 1. This I'm giving the tip. I did not do, but once I know, I can do the calculations easily. Don't think Sarvai is doing so much calculation. So minus 1 to the power. So here, so for different values of n, right? So for different indexing, so x of n by 2. So if I do this, it is nothing but for k is equal to 0, it is say x of 0. I'll substitute n is equal to 0. What n power minus j 2 pi by n. So I have substituted for n. I'm so sorry, it is for k. This is k is there. So k. Okay. Because I've substituted for k. N is equal to n by 2. So I've substituted here, I substitute for k. So that's a mistake. Okay. So x of 0 minus x of 1 plus x of 2 and so on up to x of n minus 1, last value, whatever the n value is, divided by n. So you have to just add, subtract. In our problem, if I want to determine okay, in our problem, we had this values, right? So 1, 2, 3, 4, 5, 6, 7, 8. So I have to do this calculations. It is nothing but 1 minus 2 plus 3 minus 4 plus 5 minus 6 plus 7 minus 8 by 8. So if I do this, I will get it as minus 0.5. So I get it as minus 0.5. So the fourth value is minus. So zeroth value is what? 4.5. The fourth value, which is nothing but this, is nothing but minus 0.5. Since this exhibit conjugate symmetry, the second and sixth, only the real part would exist. So this will be minus 0.5 and this will also be minus 0.5. Remember this tip, when x of k is linearly increasing or linearly decreasing, the real part of these things will exhibit the same value. So here I am summing it. So it will be minus 0.5, minus 0.5, minus 0.5. If I add it, it will be 4. If I add everything, because they are asking us to determine the output as summation n is equal to 0 to 3 x of 2n. So I need to add everything. So which is nothing but 4.5 minus 0.5 minus 0.5 minus 1.5, which is 3. So the answer is 3 for this particular problem. So we have tried to cover majority of the concepts and tried to give the tips. So I hope the session was helpful. If you have any doubts or any clarification, you can reach out to us via the email. So this would be my email ID. So the email ID is so the email ID is Sandeep dot ECE at the rate VVCE dot AC.in. So I'll try to help you if you have any clarifications or if you have any doubts regarding the signals and systems gate portions, whatever has been covered. Okay, signals and systems. Thank you for attending the session patiently. Thanks from myself and the Aisiri man. And at the end, now you will be having the end quiz. So the link will be shared in the live chat of YouTube and also will be emailed to you. Please take the end quiz and just try to explore what has been covered in this session and try to do it in a better way. Okay. So all the best wishes to you. Do well. And yeah, that's it. Thank you so much. End quiz link will be shared in live session, in your live chat. Thank you.